Login accepted.
Hey everyone, I'm super happy to be here. It's my first time in Poland. I'm French. My name is Mathis. Today we're going to talk about a side project of mine. This has completely nothing to do with my job, but my job still pays me to be here, so thank them, I guess. Who here has heard of Coding Game? Oh, very nice. Okay, 5, 6 of you. Very good. Well, let me just do a quick intro and then we can get into. It's a fun one. It's the weekend is soon. Don't worry. We're not gonna like have too much hard math explanations and stuff like that. This is supposed to be for beginners, even in machine learning. If you know a bit how code works, you'll be fine. So Coding Game, we are a website. So I work at that company. We have a completely free website where you can learn and get better at programming. By just playing. So, you know, this is my code. I did it yesterday, actually. And you like try to fight against a forest fire by cutting the trees and try to limit the losses. It's a very fun and gamified way to learn. And based on that, we also have a product that we sell to companies to test the software engineers that you want to recruit. This is done before having any live interviews to gain some time to filter out the candidates you don't need. And we also merged with CoderPad recently. This is a company you may be more familiar with, which is a platform for live interviews. So hit me up if you want any promo codes or stuff like that. I'll leave you my contacts at the end. Well, now that it's out of the way, let's get started. Do you know about thispersondoesnotexist.com? This is a website. I can show you actually. That's this website. You refresh every time it gives you a new face. The specific thing about this website is that the faces are completely artificial. They have been generated by a neural network. So here I'm showing you a few faces generated by this website. So all of those are fake. Those are not real people, except one. I want to play a little game with you to see how good you are at detecting which face is real. Okay, so there's only one real face. You need to find it. Who thinks it's the girl on the top left, number 1? Show of hands. Nobody? You all think this is a fake person? Okay. Who thinks it's number 2 right here? Okay. Number 3? Oh, more people, right. Number 4? 5? Yeah, this would be the one I say as well, but it's not that, sorry. Number 6? Ooh, okay. Number 7? Number 8? Number 9? All right, yeah, I made you a sign. Oh, come on. It's number 8, okay? The only real face in this is face number 8. Okay, so we as humans, we are not that good at detecting that kind of stuff. And it can be important. So that's why I call deepfakes, even though the definition is a bit broad. Usually it's like you paste the face of someone else onto another video that has nothing to do with it. But this can also be considered a type of deepfake. And in some cases, it's very useful to detect them. One of them, and the most important, is fake personas, so profiles on social media. If you want to sit at the front, there's a few spaces. On social media, for example, it's super easy to create a fake name, fake location, even fake tweets, because it's mostly on Twitter. But profile pictures, for a long time, you had to like steal someone else's face or something like that could be found easily. So now with that kind of platform, you can easily refresh 10 times, get 10 new fake persons with super realistic faces. So this is something that we need to be able to detect, because this is the only thing that separates the formerly easy to detect fake profiles with the new that are well made is the quality of their pictures. So how do we fight against this kind of stuff? StyleGAN2, which is the name of the neural network that's on the back end of this person, does not exist. It's a network that is hard to train yourself. There's a lot of different reasons. We'll cover a few of them later. But most of the people who actually make fake profiles on the web actually use this website specifically because it's very well made, it's fast, it's reactive, it's free. So if we manage to hack that website, it's not going to be actual cybersecurity pen testing. We win. We win against those people. First, let me just tell you how this kind of system works, this generator, because it feels almost too magical to be real. You may have seen as well recently, like in the last few weeks, DALL-E and other networks like this who generate extremely, well, not realistic, but very well-made pictures for any prompt you want. This is the kind of stuff that we call generative networks, so they generate stuff. Here we generate faces. A neural network, basically, this could be a 6 months course, or this could be a 5-minute slide. I've opted for the 5-minute slide. I hope you will be thankful for that. In very broadly, it's a lot of math operations that do stuff together, and they are trained to do a very specific task. They have inputs on the left, they have outputs on the right. This looks very mystical. If you have never used neural networks, this is actually very simple. This is a multiplication, this is an addition, and that's about it. We can modify the parameters of those two operations, but that's about it. And so by taking the inputs, which are numbers, you multiply, you add them all the way to the end, and you get a few outputs. So for example, in the case of our generator, the outputs will be the values of all the pixels in the image, so there will be way more than that. But yeah, you have to remember that this is a black box that we can train to do stuff. A few examples of that: find a plant species from a picture. There's an app, I don't remember the name, but you can install on your phone. You take a picture of any plant and it will give you its name. You film a car for insurance. It's also quite useful to process automatically. You evaluate the damage given just a video around the car. Determine when someone says that word that I'm not going to pronounce, otherwise it will wake up all the phones in the audience, but this is also neural network behind that. Detecting suspicious network behavior for cybersecurity, that is a subject that I used to work on, using machine learning to actually detect attacks. Neural networks, they can be used for a lot of stuff. And we have a type of network, well, it's actually two networks, I'll show you later, which is called a GAN, Generative Adversarial Network. So if you remember the name, well, of the network used to generate the faces, it's called StyleGAN. It does way more than just generating faces, and it can also apply various, for example, painting styles on a picture. That's why it's called that. It's been developed by NVIDIA. So GANs, they exist. They have been invented in 2014 by a guy named Ian Goodfellow. Been very, very used in recent years, but that's a fairly recent research subject. In a GAN, we have two networks. We have the generator and the discriminator. Okay, those are the two networks that are going to play together. Both of them, I told you, it's a network, a neural network is used to perform a very specific task. The generator the very specific task we give to it is you take random as an input, you output images. I'm going to tell you later how we train it to do that. The fact that it needs entropy or random numbers as an input is because since it's only multiplications and additions, if you give it the same input, it will always give you the same output. So to input some randomness, we just give it some garbage in, but that doesn't really matter. Basically, the generator, we tell it, you have to generate realistic pictures of faces. The discriminator, on the other hand, we give it an image like this, and it just has one input. It tells us whether or not this image is real. So it tries to detect whether or not an image is of an actual face. Okay, so now that we have those two networks in mind, we are going to play a game between those two neural networks. The discriminator, we will present it images that are either from a real dataset of real images or images that have been generated. Okay? And then we play it like half the images come from here, half the images come from here. If the generator manages to fool the discriminator, it means that it's doing something good. So we are going to reinforce it. We are going to reward this behavior and train it to this direction, and discriminator the other way around. And if the discriminator gets it right, so if it detects, for example, an image coming from here is real, an image coming from here is fake, we are going to reward because it detected correctly. But as you can see, the generator, it never sees any image from the real sample. So it takes a very long time to train. It only learns by trial and error, which takes a very long way. But with simple enough dataset, it can be done, like with faces. Yeah, that's basically what I said. So, difficulties of training a GAN or style GAN, which as mentioned earlier, overfitting. So, for example, we could have one of the networks that over time, it learns perfectly what the real dataset looks like. If the generator learns that, well, the discriminator can make absolutely no difference between what is real and what is fake because it's the same data. If the discriminator learns exactly what the real answers are, well, it can always have 100% performance. So this is one of the issues that can be fixed, but it's quite hard. It's very slow to converge, so the training, it trains over time over a lot of games. It's slow to converge. It takes a lot of computing power to train a GAN, not so much to use a GAN, which we'll show later. And there's also a very funny thing called mode collapse, which is slightly like overfitting. So now, what we wanted to do originally is detecting images generated by StyleGAN2, generated by thispersondoesnotexist.com. To do this, well, we could use a neural network, right? We can use, take StyleGAN's discriminator, so something that has been trained already and is very performant, or we could use our own neural network to maybe detect whether a face is real or not. But actually, if we had any of those two, it means that we have a discriminator that is better than a few years of a research team at NVIDIA, and I don't think this is a realistic expectation. So we will consider that there is no way to train a neural network to do that kind of task. Well, there is obviously, but we would need a breakthrough in research, and so we are not here for that. We need another way. Well, GANs, they are based on a game, the generator versus the discriminator. So, well, let's cheat. It's a game. We have two ways to cheat. Either we find a flaw in the rules, or we find out how the GAN actually works, how the website actually works, and try to find a way that will tell us whether or not this image is real or not. And we are going to do both. So I have here two faces. Same game. For those of you who are familiar with the website, it will be super easy. For the others, maybe not so much. Who thinks this face is real? Okay. Who thinks this one is real? Okay, yes, perfectly. I used to have another demo which didn't work at all. This is the first time I tried and it worked perfectly. Thank you. So, what we can see is, well, what made you say that this face is the real one? It's actually this one. Well, there's a lot of different factors, but one of them is quite easy to spot. It's based on something that's called the FFHQ dataset, which stands for Flickr Faces High Quality. This is the dataset of all pictures that have been used to train StyleGAN2 and thispersondoesnotexist.com. This is an open source dataset, so if we want to do the exact same work, we could. There is an interesting property that you may have spotted already. Let me make it a little more obvious, the laser eyes. Those pictures, they have been taken from Flickr, from open source pictures posted by many people. They have been cropped to be always the same size, so 1024 by 1024, and the eyes always at the same place. This is an automated process, but there's about 70,000 pictures in there, and they all look like that. Well, without the red eyes, of course. This means that StyleGAN, in that training specifically, it wants to reproduce the dataset because it wants to fool the discriminator. So what it has to do, it has to put the eyes always at the same place. The generator, if it ever puts the eyes somewhere else, well, the discriminator will just say, yeah, the eyes, they are not where I expect them, so you're out, this is a fake picture. So that's the flow that we can leverage to detect pictures that have been detected on this website. I can show you some more. You will see all the faces have the eyes at the same place. So this is a technique, it's been known for a while. I didn't invent that, but it's pretty important as a first check. Still, this is not enough for me because people can crop the picture, or we can have false positives as well. A lot of people have like their profile picture taken like this, the eyes almost at the same place. Easy to mistake them for a bot, even if they are not. So I wanted to have something with closer to 100% accuracy of classification. So exploiting the game rules, that's done. Now let's see how this GAN works and how this website works. I realized that a while ago, that if you refresh the page a lot of times, sometimes you will have twice the same picture in a row. I figured, okay, this may be a bug on my side, so I implemented a script. This is a Python script. It downloads, it's an infinite loop. It downloads the image, and it prints the beginning of the hash. And as you can see, there's a few ones here that are duplicates. So a few pictures in a row every time are going to be the same that are returned by the website. This means, well, and by digging further, I realized that there is a cache. Everyone on Earth refreshing the page at the same time will get the same image because it's made so that the website can handle loads as it wants. The GPU only generates, so the network is only called about once a second. And if we manage to, well, let's say take a copy of all those images that have been generated, we could potentially build a database of all the pictures that have actually been generated by that website. And that's exactly what I did. So, basically I have a script, pretty much the same as I've shown you, a bit more complex with duplicate checking and stuff like that. It pulls the images, so 50 images per minute. It pulls all of them and stores them on my hard drive. When I want to check if someone has actually generated their profile picture, so on that website, I just have to download the picture, compare it to all the images in my database, and this tells me whether or not this suspicious profile actually use a fake profile picture or not. Looks easy. Not so much, actually, because there's a lot of issues we are encountering. First of all, I don't have NSA budget, so I need to reduce the volume, I need to reduce the computing power. We have around 72,000 new images per day, 450 kilobytes for each. This gives me 32 gigabytes per day, or 11 terabytes a year just of images. Now, if you take into account the fact that to check for a single profile picture, we need to iterate over all the images and compare all the images in the database, every lookup will take a super long time to complete because we have to compare all the images. And we just cannot compare like the hash, because there's a compression on most social media that will prevent us to do so, so we will have to do a comparison by visual correspondence, not by hash. So yeah, storage space, I'd like to reduce that because I don't have 11 terabytes of data to spare every year. And we want to reduce the lookup time as well. So to make sure when we put an image in the system to be checked, it returns in a few seconds, ideally. Additional hardware constraints, I have this device. Does anybody know what this is? No, it's not a Raspberry Pi, actually. But it's very similar. It's a Raspberry Pi under steroids. It's called the Jetson Nano. It's built by NVIDIA. It's small, Raspberry Pi-like card, but with a GPU on top. It's very useful to do prototyping for neural networks and stuff like that, which we will use in a second. I have only 256 gigabytes of hard drive, so with the normal flow of data, I can only last a week or so for all the images. So we have to compress that. Well, we have a GPU on that card, and that's very useful because we can leverage that to run a neural network to do the processing. So instead of using a hash, like a SHA-256 hash, I'm using a visual hash. What this means is that I have a neural network that encodes a face into a vector, so into a lot of numbers. Two different pictures of the same person, even if they have aged a bit between, if they have sunglasses, the background is different. Two images of the same person should return around the same hash, so similar vectors. And two different faces, even if they have the same shirt, even if they have the same background, should return something different. So it's a way of encoding a face. I'm using something called FaceNet. It's a neural network that's pre-trained. I downloaded it on GitHub. And I'm using that to compare faces very fast. One vector, so one face compressed, is only 512 float values, or 2 kilobytes. So that's a very strong disk size reduction already. What I used to generate in a day, now I generate in 7 or 8 months. And it's also very fast to compute using a GPU because neural networks are much more efficient on GPU. That's a lot of parallel operations that GPUs are tailored for. I can also do very efficient lookup. So since what I'm storing is vectors and I'm looking for vectors of similar values, we can use Elasticsearch Open Distro, which can basically, I give it a vector and it tells me the n closest vectors that are currently in my database. So that's about it. The architecture now looks like this. So we have the same 50 images per minute. This doesn't change. Now, instead of just downloading that, we also pass it through FaceNet. So it's actually here, instead of storing an image, we store a hash. We store the vector. And this is the vector database that is efficient to look up as well. Now, when we want to check for a suspicious profile picture, we pass it through FaceNet again. So we have the vector also. And we try to find a face that matches. So we try to find a similar vector. If this is the case, well, this will return a very high score and tell us, okay, this face has been seen already and is in the database. I am also storing a very compressed, a very small version of this image so that we can also display it and compare it visually. It's helpful because having a score is good, but like, if it's 95%, how confident are we? Whether, whereas if we display the original image that we have in the database, it will be much more powerful. So, first, compared to any other technique, especially the one with the red eyes that I've showed you, or the checking of just a simple hash, MD5 or SHA-1 hash, this technique, it will be very resistant to, for example, if the person is flipping the picture before uploading it on social media, if they are taking the face and pasting it on someone else's body, they add noise, they rotate a bit the picture. Usually this will not be an issue, and the FaceNet will have no issue at all determining, okay, this still is the same person, and we can always find it in the database. Second bonus is that in addition to determining with almost 100% precision whether or not a picture has been generated on thispersondoesnotexist.com, each image is unique. I've never seen a duplicate image in like 16 or so million images indexed so far. Each image is unique and it appears only for a very brief period of time. So now if we can manage to pull someone's profile picture or someone's deepfake, run it through the database and find a match, we can figure out exactly when it was generated, because we can just store that with the vector. We store the timestamp and it will tell us, yes, the picture was generated on at that day, at that time. This can be super helpful to find out networks of bots managed by the same person. I don't have an example of a case where it was actually used, but I know that, well, if you have like two accounts with a fake profile picture generated 5 minutes apart, this can indicate that there's the same person behind, so this can be used to find evidence grouping bots, even if they have not been created at the same time. Because usually, well, the people managing botnets will not bother generating a new face, waiting for 2 days, generating another. They will just generate a few in a row. Okay, so, well, it's been nice talk. Now let me try to demonstrate that. I'm absolutely not sure it will work. It's been a long time that I've not tried it. Let's take a random picture. This is the actual website. It's being indexed real time. So I've downloaded that. It's image3.jpg. Yes, we currently have 16 million images in there. So that's about 6 months of indexing all the pictures. Of course, we do not have access to pictures that were generated before that, before the script was started, so this is a caveat. But usually accounts, well, fake accounts older than that, usually they don't exist anymore anyway. So this was that face, okay. Let me upload that. It should take a few seconds, hopefully. Yeah, well, maybe it's a bit tired today. I don't know. We'll check back later, maybe. Oh, yes, perfect. Okay, so here, this you can see I'm more of a back-end engineer, right? Super high-quality front-end. Well, here you can see the image that we have stored on the disk. It's very compressed as well. It's only like 3 kilobytes. So it's the same size as the very small vector. We have a 200 to 1 reduction in disk size with that face, but still having a visual match is super neat. We have the timestamp, it was generated. We have also the similar faces. You can see, yeah, this could potentially belong to the same person. Well, actually, those are fake people, so there's no such thing as the same person. But I also have the eye mask technique if you want. So this is a very small demonstrator. I know it's been used in real cases. If people want to make pull requests, feel free to do so. It's completely open source. So we have more than 15 million faces indexed, less than... yeah, better. You can try it for free. You go there. I think you have to put HTTPS because it's on my own website. Please don't melt my GPU. It's actually in my living room in Paris right now. If you burn my house down, it's fine, but I have my cat there. That's the only living thing I care about. And you can also have the source code and deploy it on your end if you want. Well, I gave you a good discriminator, so you remember the discriminator is the one that detects whether or not the image is real or not. Now, well, I want to give you something useful as well if you are a bad person on the internet. I want to give you a good generator as well. How to generate your own fake profile pictures or fake photos of people for whatever you may need to do so. Without being able to be detected by FADA detection and much more. Yes, I'll give you the QR code later if you want. Oh, I forgot to boot it. Well, we'll do it live. So this is a Colab notebook. I'm not sure if you know what it is. It's basically a Jupyter notebook, but it's hosted on Google servers. It's like Google Docs for Python. Super neat. So you can see I download StyleGAN 2, developed by NVIDIA. So I download the neural network that is used on this website. It's the exact same model. That's what they did. I don't know what that is. Here, PKL is the network file. So it's actually the configuration of the network that can generate faces. And now we can generate a few different faces, like this, on our own device, so it's not shared with anyone. There's no global cache that my script will download every second. Yeah, it's a bit slow to run. It's importing the network and stuff like that. And there's also a very neat thing you can do. It's that you remember at the beginning I told you that the generator, it needs random input to work. Because if we always give the same input, it will give the same image as an output. Well, there's also another property. So that property was determinism. We also have the property of continuity, which means that the random input that we provide, if we change it very slightly, the output will also change very slightly. And it can be super useful. Yes, this works. This can be super useful to generate similar faces, you know? You see what I did here? Every time I run, this changes slightly the input. The person changes slightly as well. So now you can generate a lot of different faces for the same fake person. And this can also be useful if you manage, I don't know, someone who pretends to be real. And because on this website, you have one face, that's it. Here, on this script I provide free of charge to you, you have unlimited faces for the same person. You can this is random, but you can tweak very specific parameters. Sometimes it will make like some glasses appear, sometimes a hat, a bit older, a bit younger. There's a lot of variants you can have with that. If you want the collab to do it at home, there's the link. So yeah, what I've showed is that, well, yes, StyleGAN 2 is hard to train. This is why a lot of people are using thispersondoesnotexist.com because it's super easy to work with. But you can also download it pre-trained. And you've seen the Python script is like 100 lines long, and I haven't written half of it. The rest comes from GitHub. And this completely prevents FADA style detection, so detection that I've shown you how to do by just exploiting the fact that thispersondoesnotexist.com is a lazy website. It's not been made to generate unique pictures, it's only a demonstrator, but we can exploit the fact that it has a global cache to make sure that nobody can fool us by having an original fake picture unless you have this script. Yes, so well, that's the several variants of face that that you can generate very easily. Thank you so much. We have around 10 minutes for questions, so don't hesitate. We'll have a lot of time, and even after, I'll be around, and don't hesitate to catch me after. We have a question here first.
How much time does processing one this fake image takes on this small machine? So you have only 1.2 seconds, and you have to run the neural network, you have to compress the image.
Yeah. Okay, so the question is how much time does it take to process a single image? I think I have a SSH to my own machine, so let me zoom in a bit. Server log, I guess. Yes. Okay. So here we have both scripts running at the same time. Here it's a new cycle. It means it's downloading stuff. Oh, here someone just made a query on the website. When it says new batch, it detects that there's 5 images because it processes 5 images at the same time. So indexing is almost real time. There's a folder where the first script puts all the images, and the second script processes. When there's at least 5, it takes 5, processes and indexes them. 5 here, you can see it takes around 1.27 seconds to compute the hash. So we are actually 5 times faster, so that could be much faster. Yeah, I do it in batches. If I do it single image, it's almost 1.2 seconds to process, so I figured why not. The only disadvantage to process in batch is that it takes more RAM, and as you can see, I'm consuming 3.2 gigabytes out of 3.87 because I'm running a neural network. I'm actually running the same instance on Python. Oops, sorry. I'm using the same instance to index, and when there's a query to index to check the index as well. So I'm using the same instance to waste less RAM. And there's also a very resource-consuming Elasticsearch instance which loves to have a lot of RAM, and here I don't have a lot. Yes, a question at the back?
I do have a question about the generator. Because you showed that it uses some random number, how much random numbers does it use? Only one? And how big is it? Because I'm wondering whether we can generate your vectors for all the possible values for the random number and just have
Yes. Does anyone want me to repeat the question if you were a bit far? Okay. There's actually, I think, 512 inputs, which are float numbers between 0 and 1. The search space is extremely huge for the input of the neural network. And even if you change like one of those values, you will end up with very different faces. So if you consider even like if it's either a 0 or a 1, which it's not, but we can consider that, you have like 2 to the 512 different faces, which is way too much. We can actually see, no, that's here in the collab. Yes, random range, 512, yes, and we generate it with, I think, a normal distribution of 512 values. Yes? $100. Yeah. Where did they go? Let me show you. This. I actually got it for free. It's worth a bit more. Yeah, I'm a competitive programmer. I win a lot of stuff. For example, I've won 4 Nintendo Switches so far. Please stop. So yeah, I got this for free, but there's some equipment like the SD card. This costs a lot. So yeah, that's around $100 in total to get this up and running. Yes?
Those vectors that you store in your database are kind of a hash of images, right?
Yes.
So when discriminators would like to check whether image is a fake or real, it also does a hash of this image, right?
Yes, somehow, yes.
Compared with the vector which is stored in the database, there should be we should have 100% be sure whether it's real or fake. But you said it's for example 95% sure. But when comparing hashes, we should either have it in the database or not. So
Yes, that is true for cryptographic hashing, not for visual hashing. Visual hashing, it gives you what the image looks like broadly, but I'm using broad similarity because, for example, if you add compression, well, Twitter adds a lot of compression. Images coming out of this website are 1024 by 1024. Twitter, it's only 400 by 400, so you lose some information. The hash may be slightly different because, of course, there's at some point, if you add enough noise, the hash will change. And so we are looking for similar hashes only, not exact match. And so that's why I use KNN search instead of just having an exact match that we could have as well.
doesn't changing only one pixel won't it generate totally different hash?
No, because it's not a SHA-1 hash. If you change only a few pixels, this should give the same hash or a very slightly different one, but that's what we are exploiting. Yes?
Are you testing this with like Instagram filters or stuff like that?
Sorry?
Are you testing this with Instagram filters or something?
Oh, with Instagram filters. Oh, it's interesting. No, I haven't tried that actually. That could be interesting. I think, to be honest, I think it will not perform very well with filters because the FaceNet, the network that generates hashes, is made only for like usual type faces that you can see in that kind of thing. So if you present it with a face with a filter, same as if you present it like with an animal, it will not understand what it's looking at.
I didn't mean like filters that made kind of ridiculous. I meant more like slight color changes.
That should work actually. Yes, I'm sure the network I'm using has been trained with variation on the type of images. There's a few questions at the end. You, sir. Yes. Sorry, I. Can someone repeat louder, or you? let me get closer. I get like one more word every time. Sorry. Oh, is it true that we don't know what why neural networks work? We know why they work because they work very similarly to how our brains actually work. But yes, this is a very important question about explainability of neural networks, because the network, you give it an input, it gives you a very convincing output. Usually the process of that kind of AI is very impressive, but it's kind of a black box. We cannot explain how it works internally and why it gave us this result. So it's a very active field of research to try to explain why an AI gave us this or that result. And so for neural networks, it's very important, yes. Another question at the end? Yes? Let me show, but yes, it can give you interesting results. I'll give with my face, and we'll try it. Yeah, it can sometimes give you people who very much look like you, but you will see the visual match. Maybe I need to do a different cropping. I don't know. Wait, let me do that again. I'll crop it as I want, maybe like this. Yeah, that should be fine. Okay, let's try that again. Oh, it's, well, yes, some people that look very much like you, as I was saying. I mean, how old is that guy? Is he like 13 or 30? Like it's well, no, but you can see like the visual difference. Having this visual clue, that's why I kept the small images, because it's well, it can give you with more confidence. I think we have time for one or two more questions. Yes, sir?
Just follow up on the chef being checked against the database. I was wondering what was the percentage of similarity on these pictures?
Oh,
Is it like 95%?
No, it's very small. It's very small. I don't know. No, it's usually it's extremely small. Like it's less than 5%. If it's not a very similar face, I don't display that. But yes, there's also a very weird and scary experiment you can do with face recognition. You know this website, PimEyes, PIMEYES. You upload a face, it gives you all. Well, let me just try. Okay. It will look up for all occurrences of a given face on the internet, and it's scary accurate. Like this face, look, it's all me. It's scary as fuck. Try it on your own, you will see. And I didn't give it any of those pictures. Most of them are this. I also learned I'm the doppelganger of a porn actor, which is, yeah. Even to me, it's very weird, disturbing. Okay, well, we'll take one more question, and after that, we'll take some time to discuss outside if you want. Okay, no more questions. Thank you so much.